understood 2.1 systems of linear equations, you're going to have a pretty easy time with linear inequality systems. All we do is add shading. Just, okay. I am going to show you a word problem today because it leads into what we're doing next week with what's called linear programming. So we'll get a little more detailed there. But let's jump right in. How about we solve this system by graphing? Most of the solutions we do here are graphical. There might be an algebraic solution once in a while. Most of the time they're pretty friendly. Solve a system of inequalities by graphing. Okay. And this is where if you like to use colors, it's really beneficial. Okay, so if you want, you can. Right. So we have a system of inequalities, which is basically what we did yesterday. We just didn't know it. Okay, with shading the area, the shapes, that's what we're going to end up with a lot, is the shape.
So we're just shading the shape.
So you graph the lines and shade inside, or shade appropriately. Okay. Which you guys are doing really well. Like I told you on the test, you know, none of you all passed, which was a first. So I have the utmost confidence you'll get this pretty quick. All right. If we're going to graph x is greater than or equal to 0, where does that happen?
On the y-axis.
Yeah, it's the y-axis. Right, and which way is my shading? Up? Oh, but you can't shade up because there's no line to shade up from. It's left or right. So greater than is left or right? It's to the right. So this is where I caution you just to put a little arrow. Because if you start shading, you can shade. It just creates more of a mess. Your pick. Okay. How about y is greater than 0? It's here, right? And we shade up. Now notice where the arrows are coming together. That's starting to form our shaded region, right? And the blue one. This is what I see most of you do. Does anybody want colored pencils? I have some. You're good. Okay then, don't say anything. Plus 4. And where's my shading? Down or up? Down. Okay, you see where I shade now? All the arrows come together in the middle here. Okay, not always going to happen that way, so be careful. Okay, but the red shaded up, black in, blue down. This is our shaded region. Okay. So that's my preferred, me. If you want, you can shade. Oh, bless you. Cute sneeze. Okay, you can shade initially, so I would shade this line, right? X is greater than or equal to 0. And I could shade y is greater than or equal to 0. And I could shade that one. See how big of a mess that makes? But you still, all three of them are shaded in here, correct? So that's still where you're going to end up. It's where all three of them come together. Or all two, or all four, however many you have. Okay, so what'd you do?
It's humor, dude.
I didn't do that.
Yeah, you did.
No, I didn't actually, as a student. Okay, are you good with that? Okay. So sometimes it's a shape like so. Sometimes it's not a shape and it's shaded infinitely. Let's try this.
Hey.
Are we wrapping that?
Be nice. Ooh. Good guy.
This is going to be two shaded regions that don't intersect. So these are parallel lines, right? Yeah, and the shading is actually going to go opposite directions. So y is greater than x plus 3. Is it shaded or dashed? Dashed or solid, sorry.
Oh, they're both dashed.
Yeah, they're both dashed. And shaded above or below?
Below. Below and above.
Just above on that one, right? And then the black one, whoa. Sometimes it has trouble letting go. That's the black one. Okay, so you can see that they don't actually ever intersect. Are there any solutions to that system?
No.
Yeah, this would be no solutions. Okay. Because the shading never crosses. Can you name a point that's a solution in this system?
Anything that's in the shaded region.
Okay, can you name a point that's
0, 0.
0, 0 work?
1, 1.
Yep, 1, 1 works. Okay, anything in there. So that's another option of a question. Let's see, what else? So again, you can have any manner of shaded regions. Okay. Let me see if I can find that word, a word problem that's good.
You run your forehead.
Oh. Let's take a step back real quick. Here. This region, forgot to mention this, it's called a polygon. What kind of polygon is it? Yeah, it's a triangle. Your book likes to make things really hard sometimes, and they call this a polygonal convex set. You could say that, and I could also hit you with a 2x4.
I like the 2x4.
Do it. Make it really hard so
I prefer not to do it when I'm being recorded on YouTube.
I forgot about that.
Smart criminal. Never gets caught. Okay, so that's called a polygonal convex set.
Now be aware.
Okay, you're going to be asked to identify the vertices. Okay, we've already named one, right? 0, 0. It's on. blinking green light. What's this vertex?
2, 0.
Yeah, I think you're right there. And what's this one up here?
4, 0, 0, 4.
0, 4. Okay, those are the vertices of our polygonal convex set. Nice vocabulary there, right? You will use that
Nowhere.
with word problems big time next week, so please know how to do it. Know how to find these vertices, because we're going to use them. It just turns out that if you have something you want to maximize or minimize, like business profit, and you can graph it with linear inequalities, the vertices are where that max or min is going to occur. Okay, nowhere else can it occur except at the corners. So keep that in mind. Again, I'll teach you next week. But those are the vertices. Make sure you can find them. You might have to use a system of equations algebraically. Might. Okay. We try to keep it pretty simple, stupid. Right, Brandon? Okay, so that's, I forgot that. Okay, let's,
This is why I go on crying. You make fun of me.
all right. The word problem here deals with shipping packages. Okay.
Hold your tongue when you say that.
You can measure the perimeter of one face and call it the girth of a package. If you see in the post office, they wrap the tape around the package. It's called the girth. Okay. And then the length would be just one of the other edges, the height of it. Okay. They charge extra for oversized packages. Right? Oversized packages are determined by the length plus the girth. Okay, so the package size is length plus girth. Okay. An oversized package is greater than 84 inches in dimension. Okay. Okay, or the length is greater than 60. Okay. So what size packages? Here's the question. Qualify for oversize and the length greater than 60 inches. Where's the math? So we need to pull a couple of equations out of that math statement, right? Do you have any ideas? We have some keywords there. Yeah, so we do have some keywords, right? So there's, that right there is a math equation. You just need to make it take it from English to math-ish, right? That's what I'd say. So what's the math-ish of that sentence right there? What is it? What is x? Okay, we could qualify girth, and y is length. Your book actually puts G plus L. Doesn't matter. Okay. Is there another math sentence there that we could translate to mathish? What would that be? No, we defined it. Oh, there you go. Yep. So pull the math out. Now, graph those, shade, you'll have your answers to the question, what size packages qualify for oversize and length greater than 60, right? We don't need negatives here, right? What scale should I use for my y-axis? 2s? 12s. Why 12s? That would work. Does anybody else have something different they want to use? Oh. It just makes the, okay, 12s it is. 60, right? And 84. We'll go by 12s here as well. Right. What does the first line look like? What's the y-intercept, David? 8. And the slope, Ben. Thank you. Yep. A dashed or solid? Dashed. And where am I going to shade? Above. And we'll do this one in blue, just for fun. Y is greater than 60. Shading, right? So where am I going to shade? Right, so up here, like that? Yep. So any size package you pick in this region is going to qualify for that. So what spot is this? 1, 2, 3, 36 and 72. What does that mean in the context of the problem? Yep. You bet. So it's a package of girth 36 inches and length 72 inches, and it qualifies for both charges. Okay. So be able to interpret, do the math, and reinterpret the context of the problem. Okay. And honestly, if you're going to use math after high school, this is how most of you are going to use it, is interpreting it in the context that you need to use it. Okay. Are you okay with that? All right. Yeah. I promised not to give you 6 hours of homework tonight. Oh, bad memory. Yeah. Okay, there you go. We will score 2.1 and 2.6 on Tuesday because y'all are lazy during homecoming. Are you?
Are you really sorry? I'll study that right now, but I can do it.